Hey everyone. Yeah, thanks, man, for inviting me to this conference. Okay, so yeah, I'm Karan Raheja, and I'm here to speak on the topic of attacking and defending AWS environments. Most of my talk is going to be focused around enterprise environments. Yeah, a bit about me. So currently working as a security engineer in one of very good companies, Fortune 100 company, and I'm also studying web application security, network security, trying to know more about cloud sec and DevSecOps space. The last talk I saw was very useful. I have delivered talks in the previous instances at Black Hat MEA this year and again at the Hack Summit conference. Okay, so let's just jump on the agenda for this talk. So we are going to speak about a multiple variety of things, starting with well-architected framework, shared responsibility model, going to understand a bit of mindset, attackers' mindset that makes a difference, what AWS components are being used, what are their weaknesses, how we can secure them, how phishing takes place in AWS environments, top 10 AWS security risks, attacking AWS through web apps, and then we'll look at common vulnerabilities which are found in AWS, and then in the last we'll talk about how do we defend our cloud environment from these vulnerabilities, and at the last just a bit of a overview of the cloud kill chain, which will be showed by this attack framework that. Okay, starting with the well-architected framework. So, well-architected framework, what is it, right? It is a set of best practices and guidelines which are provided by AWS to help their customers build more secure, more high-performance environment infrastructure for their applications. The primary purpose was to the why was it designed? It was designed to assist architects and developers in the same way to create well designed systems and also a very secure and a high functioning environment. So we'll just talk a bit about the pillars, right? Operational excellence, performance efficiency. What are these pillars? We know these are very fancy definitions, but going in a bit detail about what exactly do they tell us. So operational excellence is defined as the ability to meet the operational expectations, including probably high availability, high response times, and the network connectivity does not go down. So that is all about operational excellence. Coming to performance efficiency, how are you using your computing resources, and how are you, are you actually getting your business requirement, whatever is intended to come out of them, is your performance efficiency. Reliability is okay. You are facing an attack. You are facing some service or infrastructure disruption. Are you still able to run your business, or are you still able to run your infrastructure? If you are, then yes, you are reliable, right? So if your business is not stopping to function, if and apart from any disruptions, even if you are facing disruptions, your business continues to run, then you can say that okay, we are reliable. We are compliant with this particular pillar of this framework. Talking about sustainability, this is more of an environment friendly goal. So it focuses on making the maximal use of resources while at the same time not increasing the carbon footprint for the environment that we live in. Then security, of course, everyone is very concerned about the security of their infrastructure, their applications, their organizations, because security can make or break your business. It's that kind of a thing. Cost optimization, as we have been going in a very this layoff kind of scenario, so all of the organizations are now focusing on cost optimization, but AWS was focusing on cost optimization much back longer, right? So it was getting this pillar to give the organization this functionality to eliminate the unwanted costs or the resources, right, which do not satisfy your requirements. So why do you keep those resources is the primary goal. Talking about the shared responsibility model, very famous one. I think all of you must know about this, and all of you might probably already know about this. So, shared responsibility model. There are two kinds of shared responsibility whenever you are hosting anything. One is the platform security, and one is your what you host, security of what you host, right? So, talking about shared responsibility is shared between your customer and the AWS customer being, let's say me, if I am hosting my AWS infra in the cloud, then I am the customer and AWS is the cloud provider. So AWS as a cloud provider is responsible for softwares, compute, storage, or maintaining. If I speak in very broad terms, it is responsible for maintaining network connectivity between your infrastructure, and also ensuring that nothing goes down. So nothing goes down as in hardware failures or those kind of stuff, right? So availability zones, regions, they are specifically for this particular purpose. And also, as I mentioned, right, giving networking is again another thing, and also giving you proper power or proper resources to uh, run your applications on the cloud infrastructure, and at the same time also storage as well. Now, as a customer, what are your responsibilities? Okay, you told that, okay, I hosted my application on cloud, now I am done. No, it's not like that, right? You have AWS will take care of certain things, but other certain things you will have to take care of. It is not AWS's responsibility. So let's say you are running an EC2 instance and you say that, okay, it got compromised due to a package availability in at OS level, or it got compromised due to buffer overflow, right? That's not AWS responsibility. That is your responsibility as a customer. So OS responsibility, right? Making networking configurations, how you manage your VPCs, how you manage your access controls, how you manage your roles, identities. All this is your responsibility, right? Whatever you're hosting on S3, if you expose it, someone else gets the benefit of it. It's your responsibility. You will have to face the repercussions, not AWS, right? Okay, now let's speak about what is the attacker mindset for attacking the cloud. So probably this is a very well understood fact that if you know the enemy better, you are more likely to win. Right? The more recon you perform, the more you know about the target, and this also means that you need to find an efficient way of performing recon for the targets, right? So thinking outside in, right? You don't need to go at the services level and search for their vulnerabilities. You can't directly reach them. So what you need to do is you need to look for that exposed surface, right? Thoroughly mapping out your attack surface might exponentially increase your chances for successful breach. And that's what most of many products, not most, many products are focusing on at the moment: attack surface mapping. So they are looking at it, and now the same way. If we do better, if we do the tax FS mapping better, probably you find a resource which hasn't been looked after, and we get into the environment. Uh, that is a likely scenario, right? Finding cloud provider weakness is like a water. It's like finding water in desert, right? I'm not saying that you can't find it. Obviously, if you're skilled enough or you have that much time for research, for sure there are no limits, right? But it is easier to find vulnerabilities in the applications or the infrastructure that is hosted rather than finding weaknesses in the cloud providers design, or in their components, right? So look for reuse of stuff, right? We have seen this in even if we talk about on-prem infrastructure, we have seen this in a lot many places, that reuse of credentials or reuse of secrets led to some compromise or things like that. But that holds true in AWS scenario as well. Uh, and yes, automate as much as possible, because you don't have all the time in the world, right? And you will have to prioritize one thing or the other if you are having time constraints. So it's better to automate the entire process as much as possible. Primary benefit is that it saves your time, and also it helps you to eliminate your manual and repetitive effort that you put in. So, okay, how do I get into the infrastructure? These are some of the ways, right? OSINT, the good old way of doing things. Social engineering, phishing, tricking employees into accepting prompts, 2FA prompts, these things. Then vulnerabilities, whichever are hosted in web apps or exploiting some publicly exposed functions which are executing code in the backend. So if you can get that RC or SR kind of stuff, that can help you get in. Supply chain third party breach, yeah, that is very hot topic these days. So let's say you are secure, you work in a good company, you are secure, you take very good care of your security posture, but you are using a tool that doesn't have all that security measures implemented. What happens? Attackers who want to compromise your company, they come, they target that tool, get a vulnerability into that tool, and whenever a next update of that tool is pushed, or if that tool is interacting with any pipeline in your infrastructure, or if like any component, right, whatever it can reach to, if that code is pushed into your infrastructure, you are affected as well. So that is how the supply chain of vulnerability works. Again, very less likely scenario, but yes, internal employees are always a threat, and they can place backdoors, do whatever you want, just that you have to recognize that one internal employee who wants to be your asset, right? And that can lead you into the infrastructure. And yes, again, compromising any exposed service. If you have your EC2 exposed, or you have your S3 exposed, or you have your SQS roles, or whatever, like these kind of roles exposed, if you have those, these kind of roles can probably help you execute your code, and then these services can then lead you to other assets which are hosted inside the infrastructure. So yes, this again, access is through leaking and stealing access credentials, as I talked about in the first point as well. EC2, again, as I spoke about, right, a component. So EC2, if scanned, if you are scanning it properly, and if you are finding a vulnerability in that, you can connect to all of the instances which are connected to that particular EC2 instance, right? So web applications, VPC misconfiguration, all kind of these things, they are just helping factors in getting initial foothold of the attackers. And yes, once you're in, you can use Paku. It's a AWS post exploitation framework, which is developed by Rhino Security Labs, and it is a damn awesome tool, right? Okay, just want to talk about some of the resources that are most used in today's world. IAM, API Gateway, EC2, Lambda, S3, and Cognitive. We'll discuss a bit. We'll discuss more about them in a bit detail. So starting with this introduction to IAM. So yeah, IAM is a web service that helps to securely control your access to AWS resources. It can also be used to centrally manage permissions that control which AWS resources your users can access. So IAM works basically on three principles: who, what, and which. Now, how do I define it? Is not I don't define it. It's standard, but yes. So who, what, and which. Who has access to the environment, like like a service or a user or a role, and what are they allowed to do, which is certain actions, policies which are configured with certain actions, get object, disable, those things, and then what are they allowed to do. So who has access, what are they allowed to do, and which assets they can access. So that is the entire IAM in a nutshell, what IAM does, right? So primary purpose of IAM is to manage roles, manage authentication authorization within the organization, and yeah, I think it works on role-based access control policy. The IAM was devised on a role-based access control, and yeah, so IAM principles, IAM roles, users, groups. IAM principle is any person or application that uses the AWS account, or a user. Anything can be an IAM principle, whichever uses any AWS resource, right? IAM roles can be assumed by either a user or a service who wants to perform any action in the AWS. Okay, talking about IAM permissions. So IAM permissions define what actions users, groups, or resources can perform within the AWS environment. These permissions are configured through policies, and they determine access to AWS resources and services. Just talking about some of the key components, there are policy documents, actions, resources, effects, principles. So actions in particular and resources. So these define and also effect. So these three are the most critical part of a IM policy and of IM permission policy. And what they do is action defines that okay, what specific task can be performed on AWS resource with that particular privilege, whatever that policy is attached to. Resources refer to the AWS entities on which the actions can be performed, and effect is having allow or deny. So these three are the main things which you need to see when you are reviewing any AWS policy. Now, what are the policies that we have? We have managed policies, inline policies, and customer managed inline policies, and permission boundaries. Uh, So IAM permissions also help you with having granularity into your permission. So let's say you have a list of 10 users and you want to give access or write access to two of them, but you need to have only read access for four of them and no access for the remaining four, right? So it helps you with that thing that okay, because they are having the same privilege, or since all of them are users, you can still attach them with multiple different policies, and that those policies will then allow them to do all those tasks. Okay, talking about IAM credentials, they are security credentials which are used to authenticate and authorize access to AWS resources. So the credentials, they consist of the access key ID and the secret key ID, secret access key. Uh, Access key ID is a unique identifier which is used to access AWS services through CLI or programmatically is a good term. Secret access key is paired with the access key ID, and this key is used to sign requests which are made to AWS services, thereby providing kind of a secure access. They do provide secure access, but okay. So okay, IAM roles. Each role has a unique ARN, which ARN is that identifies it, and these roles define a set of permissions assigned to the role assignees for making AWS services request. Now, in most of the cases, they provide temporary credentials to the assignee or whoever is requesting that those credentials for performing for performing a specific action, right? Now, what are temporary tokens? Temporary tokens are generated by AWS STS service. STS is security token service to grant temporary access to AWS resources. Right? You can't always live with permanent credentials, and you shouldn't even live with permanent credentials because if they are exposed, they leave a huge security hole in your in your entire posture. So temporary tokens are recommended to use, and if you use them, you will be in a better position in a security posture wise. So these tokens are often used for performing federated access or applications which require short-term access to AWS resources. And keys, so as you can see, right, AKIA and ASIA. So these are two different things. So keys that begin with ASIA are identified as temporary tokens, while the key with AKIA are identified as permanent tokens, or we also say as long-term keys. So if you are getting a key which is ASIA, you need to validate if it is working or not. How much was the validity or how much is the validity. You need to find those kind of things. But if you are getting AKIA key along with the a secret access key, you are golden, right? You can if the target organization or the victim organization, they have not rotated that key, and this key is still active within their AWS infrastructure. You can query their resources. You can assume roles whatever this key is carrying, and you can do all sorts of stuff in that. Okay, talking about attacking IAM misconfigurations. So IAM again, like all components, IAM also is misconfigured. So overly permissive IAM roles can provide access to privileged sources. This is the most common misconfiguration in IAM. Personally speaking, I found overly permissive roles by going through the resource policies, evaluating them, and understanding the kind of access that they provide, and also to whom, right? So they shouldn't provide a star like kind of access, as I mentioned in the next point. most likely they are misconfigured. If resources is set to start, it's most likely misconfigured, or and if it is resources start plus allow, it's again you need to kind of look at it that okay, what is happening here. So if the resource policy is set to start for any of the permission, most likely it is not a fine grained permission, or and it is the most likeliest of all to cause a security problem. So next point is, if a user has privilege to create or update policies, or if the access control is not properly implemented, or if I say that if role assignment is not done properly, a user with sufficient privileges can create or update policies which can later be used to mount other attacks during the post exploitation phase. As I spoke in the previous slide, keys with AKIA are the real source of worry. If you find any of the AKIA things while targeting an organization, you should consider yourself either golden or lucky, and you should definitely brag about it. But if you are getting ASIA, you need to perform some kind of recon to see if it is valid or not. And IAM users without MFA. So phishing is probably the easiest to perform. You just need to write that compelling email, or you need to just do that compelling kind of action, which leads that victim to into a trap, right? So if there are no safeguard, if there are no safeguards for application after username password authentication, it makes a bit easier to for attackers to get into the infra, right? It removes a security layer altogether. So again, MFA can't guarantee you security, but yes, MFA does add to complexity for any attacker. So yes, so these were the IAM misconfigurations that are most prevalent in the industry. Not saying there are that was exhaustive list, but yes, these were the most prevalent of all. Talking about defending, how do we defend IAM? So defending is, of course, principle of least privileges. So try to give as much as least access as possible, and build the resource policy, as granular, as fine-grained as possible. Enable your auto rotation for credentials, probably 30 days, 60 days, but definitely not more than 90 days. Even if your AKI is leaked, then also you can be okay. That okay, at least it was rotated after 90 days and it's not valid anymore. So and then yeah, enforce MFA for each account is another security measure that you can have. So, what is the principle of least privileges? Principle of least privileges is a concept, where a user is given the minimum possible level of access, which is required for to do a specific job. This can be applied to the users, roles, policies, whichever are configured in the cloud environment. That can be implemented on those. And why is it important, right? Like what does it help us with? So it helps us by limiting your super user and administration and administrator kind of privileges. You don't distribute that to everyone, and helps in managing your authentication authorization stuff, and also helps in your compliance and auditing engagements. Okay, talking about AWS API gateways. So where are API gateways coming into this? So you as a internet user, you send your traffic to an application which is hosted on AWS, but most likely that traffic from your browser or your site will be received by API gateway, and then it will be transferred to the application. So it is an HTTP based, and yes, it is an AWS service which is used for creating, maintaining, and exposing the REST and HTTP kind of APIs. Uh, so because it is a multi-dimensional thing, it supports client server communication. It supports all kind of communication which a web application can have, which is which composes of HTTP based communication, your stateless client server communication, and also it can implement your standard HTTP methods such as get, post, put, those kind of things. So WebSocket APIs are created by API gateways. They stick to the WebSocket protocol, and enable stateful full kind of bidirectional, full duplex communication between client and server. And they also route your incoming messages based on the message content, whichever is coming. So this URL in the last, this is mostly how this API URL looks like when it is exposed via API gateway. So this diagram shows that okay, you can build your API in Amazon. You can build your APIs and expose via Amazon API Gateway. But what Amazon API Gateway provides is, you or your developer customers with an integrated and consistent developer experience for building AWS serverless applications. And API Gateway handles all the tasks which are involved in accepting and processing up to our, I don't know how many million concurrent API calls. And these tasks include traffic management, authorization and access control, and API version management, and those kind of things. So API Gateway acts as a front door for applications to access data, business logic, or functionality from your backend services, such as workloads which are running on Amazon Elastic Compute Service, and then code running on AWS Lambda, or any data stored in DynamoDB, those kind of things. So let's talk about attacking AWS API gateways. So gateway misconfigurations include uh, lack of authentication of endpoints. Now, since there are so many APIs that directly go to the backend for performing variety of stuff, there is no authentication with the incoming requests. It will create a lot of ruckus for the backend programming processing systems. Also, there might be some endpoints which are behind authentication in a normal application flow, but due to API gateway misconfiguration, those endpoints might directly be available, defeating the whole purpose of implementing the authentication checks. Misconfigured private API gateway. Why is this coming into the misconfiguration? Is because there are some APIs which are required by the backend systems to perform a variety of tasks. Now, since these APIs are directly consumed by the backend, they need to be misconfigured with the private access. They need to be configured with the private access, and minor misconfiguration can lead to exposure of internal API and can potentially result in other attacks. Poorly configured WAF. Yes, if the incoming requests are coming at a rate higher than what can be processed or what can be handled by the backend systems, then it will create a traffic logging situation at the backend, and the backend systems may falter. DOS, denial of service. Yes, in an extreme situation, the above scenario, if it's a poorly configured API gets above, it can lead to a denial of service attack as well. So this is a basic demonstration of a header smuggling attack, because header smuggling attack can also be performed against API gateways. So how header smuggling attack is performed is an attacker tampers with the request in a manner which is not expected by the server, and mismatching requests on the backend and the front end are the primary cause of this vulnerability. So they can force the leak of data and secrets, as well as they can bypass your IP restrictions or header restrictions, or those kind of things. And uh, let's talk about defending API gateways. So defending, yes, enable rate limiting. You need to be very secure from DDoS attacks, DOS attacks. So you need to enable rate limiting. Also, for DDoS attacks, you can use other components like Shield to prevent you from those, because Shield is an advanced protection for your specifically for DDoS situations. So that can be used. Then logging and monitoring, so that you can monitor your usage and the traffic metrics, whatever is coming onto your API gateway, whatever your API gateway is handling. Then alarms should be configured with a specific limit and should be triggered whenever a certain situation is met. So it helps you to create an alarm on the highest limit that your API gateway can reach or can handle on its own. And then you can scale up your resources so that your incoming traffic can be handled. So yes, you can monitor your security best practices using AWS Security Hub. Talking about EC2, very famous service, everyone knows about it, but still a bit detail into this. So EC2 is a service which provides you a highly scalable compute capacity in the cloud infra, and it is dependent on the user to determine the virtual servers, how many they want to launch, with what config they want to launch. So whatever operational requirements they have, that will determine what kind of resource, what kind of EC2 instance they want to launch. Now there are multiple advantages over on-prem counterparts. Some of them being costing, reliability, uptime, maintenance. Yes, so it does provide these kind of advantages, but so you don't have to, so you don't have to worry about your hardware problems, costing, all those kind of things. But there is a generic notion that resources on cloud are more secure. So it is partially true, not fully true. It is partially true that okay, they are comparatively more secure than their on-prem counterparts, because in on-prem systems you have to think about physical attacks, other kind of those kind of attacks which are not possible on cloud basically. So IAM provides added protection. You don't have to think about your roles and those kind of things. So it's not that the resources which are hosted on cloud are secure by default, but yes, they do have a layer of added security onto your resources. The biggest benefit of using EC2 is that if EC2 infra, whatever is running on EC2, can be scaled up or down based on the need and the operational requirements. So let's talk about how do we attack EC2 misconfigurations, and what are the misconfigurations that are present. So using public and unencrypted AMIs can lead to a supply chain attack within AWS infra. And there have been reports in the past where the attackers infected the AMIs, put out in the open source, and then someone used those APIs into their cloud infra, which then led their cloud infra to become compromised. Get they had to accept the breach and all those kind of stuff. So deploying private instances is a misconfiguration which is often encountered when AWS administrators fail to make sufficient security arrangements on EC2 instance, which are not intended to be exposed to the public internet. So that is the main basic funda of how this misconfiguration happens. Stolen or leaked credentials, these are probably the most common way of getting access to application services in the cloud, apart from obviously the web vulnerabilities. But these are still, as I said, right, these are one of the most famous ways. So SSH brute force. Now this is a very interesting use case that I recently encountered. So what happened was that I deployed an EC2 instance in its default configuration. Uh, I didn't apply any security patches. I didn't do any VPC configurations. That did not restricted from the internet traffic. I allowed it, and a public traffic, allowed all public traffic. And within 30 minutes, I was monitoring my auth.log file. So it shows how much attempts you have done on your SSH service, or how much attempt anyone has done on an SSH service, authentication attempts. It showed that there were 85 attempts, 85 to 90 attempts of authentication within the first 30 minutes. So that means someone in the world, or someone on the internet, has that script running, has that bot running, which will scan for all the open EC2 instances, search for default credentials. And not just that, it also uh, ran a proper word list kind of a brute force. So it was not a targeted brute force. They used a default username, which was Ubuntu, and then used some kind of word list, and then they were just brute forcing the SH login for EC2. So how do you defend EC2? Is that you should create separate instances for separate workloads, which will ensure that okay, vulnerabilities within one application or within one OS cannot impact other workloads. I cannot impact services running on other workloads. So again, least privileges in IAM. Least privileges is like a thing which should be everywhere. Least privileges like if you don't have anything in a security, you should at least have your least privileges. Now, secure the network at VPC level. You need to do all your networking configuration and all. You should have a monitoring and a system metrics logging system, which helps to detect any issue, including the security issues. Now you should also regularly patch and update your existing EC2 workloads. Coming about the Lambda service, Lambda is a compute service that lets you run code without provisioning or managing servers. So you can organize your code into Lambda functions. What is a function code? It is a function. Function code is a small anonymous function which is used to perform certain actions whenever a predefined situation is or a condition is met. It is highly scalable because it runs your function only when needed, and it also scales automatically based on requirement. Lambda runs your code on a high availability infrastructure. It also takes care of your administrative tasks, so you don't have to worry about any of that stuff. You just need to run your code, provide it a script, it will run, and it will give you the output, and it will do whatever action which that code is telling it to do. So now you just need to ensure that your whatever code you're supplying is in one of the language runtimes whichever Lambda supports. Lambda is mostly focused on event-driven architecture. So AWS services which are being used in environment generate events, and then they act as an event source for Lambda. Now, some of the events which can be used are, yes, whenever a table is updated, do X action. Whenever messages arrive, do Y action. Those kind of things. So whenever, as I said, right, whenever an event happens, Lambda comes into the picture if it is configured that way. Let's talk about attacking Lambda. So I haven't mm, came across a Lambda vulnerability till now. Apart from web-related vulnerabilities, I didn't have that rate table API endpoint, but I did saw RC happening in a Lambda function. That it was not done by me. Some researcher was doing it. I saw that. But okay, so let's talk about predictable API endpoint URL. So this misconfiguration is in Lambda is that the API endpoints can be predictable in their default configurations, and if the developer or administrator they have that human tendency of writing easy names or easy to remember names, then of course this is a reality that is going to happen. Web related vulnerabilities, as per what I saw and whatever I read about whenever I was preparing for this talk, I just saw that all the issues which are present in web applications can also be present in AWS Lambda. There was no issue which I did not see apart from web application specific issues such as uh, uh, IDOC kind of things or prioritization kind of things. Those things I did not see, but RC, SSRF, XXC, XSS, SQLI, all kind of things they were happening. Now let's talk about how do we defend Lambda. So we need to provide one IAM role per function. What this means is that all the Lambda functions, whichever are present, they need a single relationship with an IAM role. They function with an IAM role. Now, this ensures that even multiple functions with the same policy are triggered at the same time. All functions will be granted at the same time. So this is like if one function is running, it should not impact other function, or the it should not have multiple roles. Uh, how do you protect the secrets? So using encryption helpers or AWS system managers parameter store that can help you to protect your secrets. Implementing API authorization, WAF, those kind of things can probably help you to defend your Lambda instance. Okay, let's talk about S3. So S3 is having a globally unique naming convention. No two buckets can exist with the same name. So object versioning again, if even if you want to delete an object on S3, it will get updated as a V1, and your new object will come as a V2. So the object does not get overwritten, and also it is retained. From my personal experience, S3 has been the most misconfigured AWS service apart from EC2. and that's because of, probably because of its usage metrics as well across the industry, but also because probably they're so easily misconfigured, or probably I think that's the second reason is what is most prevalent. So they can be used for phishing. So this was a new attack vector that I came across, that attackers can host attacker websites on S3 buckets. Now, since the requests are coming in from S3, the source will be termed as a valid source because it is trusted entity. It is coming from Amazon's infrastructure. Because the email generated from a legit AWS infrastructure, it will not be marked as malicious, and it will bypass the email filters that are deployed to prevent such phishing attempts. And the last point, it's a truth that no one can deny. It can be a gold mine of information if you are on the right place at the right time. You can get all sorts of things into in an S3 bucket. So how do we attack S3 misconfigurations? Uh, we obviously, if we do our recon properly, we can get publicly exposed buckets or public exposed objects which are located inside buckets. Data present in S3 buckets, which is present in plain text, can be a cherry on the cake, because since an attacker dumps a S3 bucket, every information is present in plain text, and yes, you can sell your data or you can do whatever you want with that data. Access policy related misconfiguration. So access policies can facilitate unintended read or write access to the attackers. So if you are not configuring that properly, you are inviting attackers to come and destroy your infrastructure. Absence of authentication authorization controls. So if an application is using S3 buckets to store the application data, it should have proper authentication authorization controls from public access as well as internal network. Uh, Coming on to how do we defend S3 is, we first of all we need to disable public access for the buckets which are not intended to be publicly exposed. We should monitor all the S3 buckets, attach relevant rules and policies, use assumed IAM roles for read and write access to the bucket, instead of giving explicit permissions to individual users. And we need to use pre-signed URLs for sharing. Now, by default, all Amazon S3 objects are private. Only the object owner has permission to access them. However, the object owner may share objects with others by creating a pre-signed URL. And a pre-signed URL, how is it different is because it uses security credentials to grant time-limited permission to download objects. Talking about AWS Cognito, so Cognito enables simple, secure user authentication, authorization, and user management for web and mobile apps. With Cognito, a user or a visitor can sign in with username and through Amazon, or through a third-party app like Facebook, Google, or Apple, or any of the SSO provider. The main functions of Amazon Cognito are that it manages user authentication authorization. It saves encrypted information as key value pair. So Cognito associates your datasets with identities and saves encrypted information as key value pairs. It doesn't store them in clear text. So that's a very kind of a secure architecture to have. And yes, let's talk about the user pool and data pool. So these are very critical when we talk about AWS. So user pool is that, let me say it this way. Amazon Cognito collects your user profile attributes into directories which are called user pools. So if you are a user who is trying to visit Amazon, who is trying to use Cognito for your authentication authorization stuff, it will collect your profile, it will extract the attributes, and then it will store that in user pools, and then it will determine that, okay, if you are entitled to access or not. Identity pools are that it consists of end user information. So which client access platforms, access platforms you can access, what devices, you know, uh, what other kind of resources you can access is how identity pools work. So just for this cognito, this is a sample scenario. In this scenario, the user needs access to DynamoDB instance. So what the user does is he or she, whoever the user is, they go to a sign-in form and submit the credentials. Now, AWS Cognito is managing the authentication and authorization of that entire application. So what it does is it receives the credentials, validates it against the Amazon Cognito Sync store, and sends the access key and the token to the user to request the access. The user supplies the received credentials to Cognito Identity Pool. The identity pool identifies the resource which is accessible by the user requesting the access. Uh, it then redirects the user to the service where the user has sufficient privileges to perform the required action. So that is how a Cognito performs in a real life implementation. Now, how do we attack Cognito? Now, attacking Cognito is not very straightforward, and it's I haven't seen it in wild happening till now. But this was what I got when I was doing my research. So Cognito's identity pool ID is shown in HTTP responses. So this is obtained whenever a Cognito ID pool ID is shown, identity pool ID is shown in HTTP response from the web server. If your application is responding with identity pool ID in the response, and now since identity pool ID is disclosed, identity pool ID can allow the attacker to fetch temporary AWS credentials for an unauthenticated role with the help of Boto3 library. Rest everything is a game of what privileges does the disclosed identity pool ID has. Uh, Talking about Cognito client and user pool IDs, so if Cognito client and user pool IDs are being disclosed in HTTP responses, and if Cognito user registration is enabled, which they are enabled by default, so that's a by default by design feature, and that can allow an attacker to register for a valid user using a valid ID. Uh, so that is how these two attack scenarios look like. Then the below two they are very generic. Secrets leakage through JS files. Again, you can do the attack scenarios described in the above 2 points. And user enumeration. So this can happen only when Cognito returns a username exists exception when trying to register with a username which already exists. So that user enumeration can happen, but and also you can mount your brute force attack as well onto this. So how do we defend Cognito? We need to ensure that no unintended functionalities such as register or sign up functionality are exposed to the users. We need to validate our responses, whatever information is being passed to the end user. We need to implement MFA, and then we need to review the IAM policies which are attached to the unauthenticated role, because that role can be assumed whenever identity pool ID is disclosed. So talking about subdomain takeovers, how do they happen? Subdomain takeovers have been very common in AWS in the past. So there's a dangling DNS record, and how that comes is that okay, you have a you have your S3 bucket and you have your DNS mapped to it, or you have your EC2 instance and you have your DNS mapped to it. Now either of that instance is taken down for any XYZ reasons. So what that happens is that DNS is still left to point at that particular resource or that particular instance only. Now attacker, what they do is they either brute force your bucket name, whatever was configured with the DNS, or they get that IP, elastic IP, whatever was used for the DNS to point, and then they claim it. Once they claim it, now the DNS is again valid and it points to the attacker control infrastructure. So that is your subdomain takeover in a nutshell, right? So the only hard thing to do here is that you need repeated efforts to get your IP or the bucket name to the exact thing whichever that organization was using. So if DNS record still points to that IP or bucket, you get a takeover. It's a game over thing. So let's talk about phishing in AWS environment. So phishing, consists of probably five things we are talking about. Traditional phishing, which is not specific to AWS. So traditional phishing is action phishing, which is tricking a target to extract some valuable information. Then it's either about delivering an exploit via some XYZ mechanism, or it's about harvesting credentials by luring the user into doing some stuff or submitting their credentials. So let's talk about some phishing mechanisms which are very specific to AWS. These are device authentication phishing, cloud formation stack phishing, ASIM email validation phishing, and AWS SES verification phishing. Now, I'll just talk about in a bit in detail about these. So, device authentication phishing is that whenever you are having an AWS SSO and you try to log in via CLI, now attacker, you know, these attacker who knows your SSO URL can initiate the flow and just needs to convince the authenticated user to accept the prompt. Once they do that, they have that access valid for probably 6 to 8 hours, and because they have tricked the user into accepting that prompt, which was a kind of MFA. So this is again not preventable with your MFA implementation.
You
Cloud
have
formation stack. Yeah. Sorry.
You have 5 minutes left.
Yeah. Sure. Okay. So cloud formation stack phishing is your stack phishing, so if you send this URL into a benign URL and send this to a victim, so they can they if they click on this, what they can do is they can go to your cloud formation stack and click on it. So a malicious stack is deployed into their cloud infrastructure. uh, ACM validation phishing and SES verification phishing. So ACM validation phishing is your certificate authority related phishing, wherein you can get valid email addresses from AWS, and so if you approve this request, it will grant an attacker to grant attacker a valid certificate. And SES is something that helps you to send or receive email. So now this verification email in this particular scenario is that can be requested for any domain or email address. Now this verification process only depends on the GET request, which is in the verification email, and because since it's only a GET request, it is susceptible to both human error and all the automated exploits that are there. So let's share. So just one thing. So yes, this is the best practices that we have. Probably the last slide for the day. And so yeah, MFA, as I spoke in the beginning, it is something you know, something you have, or something you are. Uh, Something you know is username password. You have is your MFA application. Something you are is your biometrics. MFA can be enabled at your AWS root or IAM users level, and it should be enabled. You should have kind of any hardware authentication or a virtual authenticator which can help you with your MFA kind of things. Instead of permanent long-term or short-term credentials, you should only use your temporary, very short credentials which are valid for like say 15 minutes or 30 minutes, just for those performing tasks, and remove all the root user access keys, and promote your usage of your secrets manager KMS, because they help you to secure your secrets. So that was all about it. I probably have some more content, but time limitations. So I'll publish this slide. Just give it a go and let me know. Open for feedbacks. Thank you so much.